Dear student, in this lecture, we are going to discuss about a Dalton atomic theory. Dear student, it was the Greek philosopher known as Democritus who proposed that a matter consists of indivisible, tiny, small particle, and that particle is known as atom. Atom is derived from a Greek word atomus, which mean that indivisible or uncuttable. So, according to Democritus, matter consists of a small, tiny, indivisible or uncuttable particle, and that particle is known as atom. This was just a theory, or it was just an idea of a Greek philosopher Democritus. However, it has no mathematical basis or experimental basis. It was a British chemist known as J.J. Known as John Dalton, who in 1808 proposed his own atomic model, and that atomic model is known as Dalton Atomic Model. Dalton basically supported the ideas of Democritus with his data and proposed his atomic theory or atomic model. Basically, dear student, as per Democritus' atomic theory, it was just an idea that atom is the smallest particle of a matter. However, experimentally and mathematically, the idea of Democritus was validated by Dalton, and on the basis of that, Dalton proposed his own atomic theory. Now, question here is that how Dalton proposed his own atomic theory. Dalton proposed his atomic theory on the basis of law of conservation of mass and law of multiple proportion. So, on the basis of law of conservation of mass and law of multiple proportion, Dalton proposed his atomic theory. Dear student, law of conservation of mass, basically it states that mass of initial element before a chemical reaction is equal to mass of a final product or a compound. So in any chemical reaction, the mass of initial elements, basically, when they are going to combine, that mass is basically equal to the mass of the final product, which is formed due to the combination of a mass of initial element. So the mass of initial elements will be equal to the mass of the final product or final compound. So we can basically represent a law of conservation of mass by a chemical equation. Consider that we have a chemical reaction for water. Water as its formula is H2O, and it is formed with the combination of hydrogen molecule. Suppose we combine two hydrogen molecule with oxygen molecule. So whenever two molecules of hydrogen combine with one molecule of oxygen, they will basically do a chemical reaction. And due to a chemical reaction, they will form two molecules of water. We can basically represent the chemical reaction of these two hydrogen molecule with oxygen molecule as two hydrogen molecule combine with oxygen on the reactant side, and they basically do a chemical reaction, and with the chemical reaction we get a product, and the product is basically two water molecules. So now, dear student, keep in mind that the mass of these two hydrogen molecule and oxygen molecule as per law of conservation of mass will be equal to the mass of two water molecules. Student, since you know that the atomic mass of hydrogen is 1, so here two hydrogen molecule here basically here are two hydrogen molecules. So the hydrogen two hydrogen molecule have an atomic mass of 4 AMU. Similarly, atomic weight or atomic mass for oxygen atom is 16. So one molecule of oxygen atom is basically has an atomic weight or mass will be 32 AMU. So now, student, please keep in mind that it is necessary to write the hydrogen and oxygen during a chemical reaction in a form of molecules, because they are always present in a diatomic form. So due to this, the chemical reaction will be represented between hydrogen and oxygen in a form of molecule. So the mass of hydrogen molecule is 4 AMU, and whereas the mass of oxygen molecule is 32 AMU. So the total mass of hydrogen, two hydrogen molecule and one oxygen molecule will become 32 plus 4, it will be 36. So dear student, on this left side of on the reactant side, the mass of hydrogen molecule and oxygen molecule, the total mass of hydrogen and oxygen molecules is 36. So in order to the mass law of conservation of mass basically said that the mass of initial product will be equal to the mass of the final product. So the mass of the initial compound or initial product is a reactant is basically it is 36. So the final mass of the final product will also be 36. Since you know that the two water molecule have two water molecules, since you know that hydrogen atom has one atomic mass, and the two hydrogen molecules will have 4 atomic mass, and similarly oxygen has a 16 atomic mass. So the two hydrogen molecule will have 32 atomic mass. So if we combine the atomic mass of two water molecule, we get 36 net atomic mass as 36, which means that the atomic mass of initial reactant is basically equal to the atomic mass of final product. So this was basically first experimental observation of by Dalton, which is based on a law of conservation of mass. And on the basis of the law of conservation of mass, basically, Dalton proposed that atom is a part of matter and it cannot be created nor been destroyed, which means that the initial mass of atom will be basically equal to the final mass of a new atom which is formed due to a chemical reactions. A final mass of new compound which is formed by the chemical reaction of the atom which basically initially combine in a reactant site. Similarly, the Dalton also considered the law of conservation or law of conservation of multiple proportion or law of multiple proportion, which basically state that the ratio of atomic mass of initial reactant and final product of a chemical reaction is in the form of whole number. So basically, the ratio of the atoms which basically combine in a reactant side, they will be in a form of whole number, and similarly the product which is formed, if there is a different compound form, their ratio will be also in a whole number. So they which mean that the ratio in a whole number means that atom is not basically uncuttable, and its is a smallest particle. So we can basically represent a law of multiple proportion with the equation of with the chemical reaction of a water. Since you know that if we do a chemical reaction of water where the two hydrogen molecule combine with oxygen, we get two H2O or two water molecules. So initially the mass of two hydrogen molecule is equal to 4 AMU, and whereas the mass of oxygen molecule is 30 AMU. If we take the ratio of oxygen and hydrogen, if we divide 32 AMU by a 4 AMU, we basically get a ratio of 8, which means that the mass of initial product is basically present in a whole number. Similarly, the mass of two H2O water molecule is 36. It is also present in a whole number. So this state that atom is basically present in a form of a whole number, or it is basically a smallest particle. So on the basis of the law of conservation of mass and law of multiple proportion, Dalton proposed his own atomic model. So dear students, let us discuss the most important points are the key points of Dalton atomic model. Dalton atomic model states that smallest particle of matter is called an atom. Or in the other word, atom is a smallest particle of matter, or a matter is made up of smallest indivisible tiny particles, and these particles are known as atom. Second key feature of Dalton atomic model is that atom cannot be created and it cannot be destroyed. Whenever there is a chemical reaction, atom will react with other atom. They will form a new compound, but they will always remain present in a new compound. They basically they do a chemical reaction, but they cannot be destroyed or they cannot be created. They will exist. Another key feature of Dalton atomic model is that atom of same element will always be identical. Suppose we have oxygen atoms. So every oxygen atom will have same mass, it will have same atomic number, and it will always have a same atomic weight. It will never be different from the other oxygen atom. So always, every time, atom of a same element will always have a same atomic mass, atomic weight, and even shape. They will always identical, they will never be different. Similarly, Dalton proposed that atoms of different elements have different masses and properties. And keep in mind that on the basis of Dalton atomic theory, Dalton proposed that atom will always have a different atom will always have a different atomic mass and atomic and properties. Please keep in mind if we have oxygen atom and a hydrogen atom, so oxygen atom will have same masses just like oxygen atom. Similarly, hydrogen atom will have same mass as hydrogen atom, but their masses and their properties will always be different from each other. So oxygen atom will have its own properties and hydrogen atom will have its own properties. So they will never be same because the element or atoms are different. So different atom or element will have different masses and as well as different properties. They will be same from for themselves, but their properties and mass will be different for different elements. Different Dalton proposed that chemical reactions are the rearrangement of atoms. So basically, whenever hydrogen molecule combine with oxygen molecules, they basically form H2O, which is a rearrangement of an initial reactant. The final product is formed due to rearrangement of atoms of the initial reactants. Student Dalton proposed that compound are formed due to combination of two or more different atoms. Whenever two or more different atoms combine, they form a compound in a chemical reaction. Suppose, just we have previously given the example, whenever two hydrogen molecules combine with oxygen molecule, they basically form H2O, and that will basically a different, they come the H2O, which is compound, which is formed due to combination of two different elements or atoms, which are hydrogen and oxygen. Similarly, we can do a chemical reaction of hydrogen with a fluorine on reactant side, and whenever the molecule of hydrogen combine with the molecule of fluorine, we basically get hydrogen fluoride. So these were basically five key points of Dalton atomic theory. So let us conclude the Dalton atomic theory. Dalton atomic theory said that atom is the smallest particle of matter, and it is undivisible and uncuttable. Atom cannot be created, and it cannot be destroyed. It will always remain. Uh, an atom of the same element are always identical. Hydrogen atom will be always identical with hydrogen atoms, and similarly oxygen atoms will always be identical to the oxygen atoms. Atoms of a different element have a different mass and as well as properties. So each atom of a different element will have a different atomic mass, and their properties will also be different. However, for their self, like hydrogen atom will have same atomic mass with hydrogen atom, and its properties will be same as hydrogen atom. However, for different elements like hydrogen atom with oxygen atom, hydrogen atom will have different properties and mass than the oxygen atom. Chemical reactions are the rearrangement of an atom. So just like just like the formation of water, hydrogen atom or molecule basically combine with oxygen molecule. They form 2H2O, and the 2H2O on the product side is basically a rearrangement of the hydrogen molecules. Compounds are formed due to combinations of two or more different atoms. Whenever two or more different atoms, such as hydrogen, which is different than fluorine, when these two combine, they form a compound which is hydrogen fluoride. So, dear student, this is all about the Dalton atomic theory. So, thank you for watching this lecture.